Jai Hind all of you. Today we will discuss the phasor representation of alternating quantities. We know that our alternating quantities are sinusoidal and their mathematical equation of alternating quantity is, suppose it is current, then it is mathematical equation is I is equal to mathematical equation, suppose it is AC quantity is current, then I is equal to Im sin omega t. It is the mathematical equation of mathematical representation of alternating quantity. Now and its waveform is sinusoidal, its shape is sine waveform. This is the sine waveform, this is the small I, and this is your peak value of current Im, and this is your 2 pi time period. This axis is taken as you can say theta, you can say time t, theta is equal to omega t also. Omega is speed or angular frequency in radian per second. So this is the mathematical equation or mathematical representation of alternating quantities, and this is the waveform of the alternating quantities. And this alternating quantity or AC quantity can be represented by a phasor. So what is a phasor? Now the question is, what is a phasor? Phasor means a line having constant length and rotating continuously anti-clockwise direction. A phasor is defined as a line having constant length equal to peak value of AC quantity and rotating continuously in anti-clockwise direction. Rotating continuously, we can write here rotating continuously in anti-clockwise direction. This is the meaning of phasor. So we have to remember this. What is a phasor? A line having constant length equal to peak of the AC quantity and rotating continuously in anti-clockwise direction. This is meaning of a phasor. Now how we can represent this mathematical equation or this waveform with a line, and line can be, suppose this is the length of the line, it will be equal to length equal to peak value, this is equal to peak value, and it is rotating continuously in anti-clockwise direction across this, you can say, point or axis. This quantity is rotating continuously in anti-clockwise direction. So this length rotating continuously in anti-clockwise direction represent this AC quantity or this quantity. So this is meaning of a phasor. Now how to explain this? How to prove this? To prove this, suppose our AC quantity is a current and this is the waveform of an AC quantity. Now we can see that this is the peak value of our AC quantity. So we are taking a line which is whose length is equal to this peak value of the AC quantity, and suppose this line is this OA. This line is this OA having an arrowhead and it is rotating. Suppose this line now, which is equal to the peak value of this AC quantity, this peak value this is equal to peak value and it rotating continuously in anti-clockwise direction. So this line rotating continuously in anti-clockwise direction represents this mathematical equation or this waveform. This is meaning of phasor representation of AC quantities. Now you can see that when you will see the projection of this line on y-axis, when you observe projection of this line on y-axis, then you can see that this line rotating continuously in anti-clockwise direction will exactly represent this waveform. How it is? Suppose when the quantity is in position OA, when it is in position OA, what is the projection of OA on y-axis? You can see from this diagram, projection of this OA on y-axis, this projection on y-axis is 0. So this point we will get A. Now it is rotating, and suppose by rotating it comes in this position at B. Then what is the projection of this AC quantity? This rotating line on y-axis, the projection of this rotating line on y-axis, it is this much projection. This is meaning of this, and this projection of the line on y-axis is this one, and the point is now represented, this point B, point is this represented. Now suppose by further rotating it comes to here, and now the projection becomes equal to this much. So projection becomes, when the AC quantity reaches or this line reaches here, its projection on y-axis is equal to its peak value, and this point is now represented. Similarly, when it reaches at point D, here the projection of this line on y-axis becomes equal to this much, means representing point D. Further rotation it comes to E, and its projection again becomes 0, means we have got this point, and it is continuously rotating, it comes here, again projection on y-axis is taken, which is negative this much. Negative this much means we are getting this sine wave, and we are getting this point or this point. Similarly, it comes here, the rotating comes here, and then our projection to the y-axis becomes like this, yani peak value, and we get this point or this point, and similarly rotates, it rotates, comes here, projection becomes this much, and we get this point, it comes here, and we will get this point. So in one rotation, in one complete rotation of this line, we get one cycle of the AC quantity. This is, so it means this line having length equal to peak value of the AC quantity and rotating continuously represents exactly this waveform or this mathematical equation. So this is how we say that a line having length equal to peak value of the AC quantity represents an AC quantity. So this is phasor representation, and this is used in analysis of AC circuits, means addition, subtraction, multiplication and division of alternating quantity, which we can see that in the mathematical form addition is very difficult. Addition, subtraction, any mathematical operation on the AC quantities will become very difficult. Suppose there are number of currents I1, I2, I3 represented in this mathematical form or this waveform, their addition, subtraction, multiplication, division, etc. is very difficult. That's why this phasor method of analysis is used for analysis of the AC quantity, that is mathematical operation of addition, subtraction, division, multiplication. Now we will go ahead. Now concept of phase of an alternating quantity. What is meaning of phase of an alternating quantity? We have seen that alternating quantity is represented by a phasor. Phasor means a line having length equal to peak value and rotating continuously anti-clockwise. So it means the phase angle of an AC quantity, it is continuously changing from 0 to whole cycle, that is 2 pi. Suppose this is your reference axis, this is our reference axis, our AC quantity is continuously rotating anti-clockwise. When the AC quantity is here or phasor is here, the angle from this reference or x axis is 0. When it moves up to here, the phase angle is phi. Similarly, when it comes here, the angle is 90. When it comes here, angle is 180, and when it comes here, the angle is 2 pi. We will measure the angle from x axis or reference axis. So this will be the angle. Suppose the AC quantity is here, phasor is here. So then this will be the phase angle, right? It means range of the phase angle. What will be the range of phase angle? Now we can clearly see that it is between 0 to 2 pi. 0 to 2 pi radians. This is the range of the phase angle. So we can see when it is here, the phase angle is 0. When it is here, phase angle when our phasor while rotating comes here, right, then we can see that this phasor here represents this point. This point, when we drop a perpendicular on x axis or reference axis, we will get this angle. So this will be, this axis is theta axis or omega t axis or time axis. Theta axis, omega t axis or time axis. So this angle we will call it phase angle. When it was here, phase angle was 0. When it is here, phase angle phi. Where it is here, phase angle 90, and so on. So phase angle is continuously varying between 0 to 2 pi, and at a particular instant, you can note it down, at a particular instant the phase angle is something constant. Like at this instant phase angle is 90, at this instant phase angle is 180, and at this instant it is 270. So this is meaning of phase angle of an AC quantity. It will be fixed at a particular instant, but when the time varies, it changes. And general equation of an AC quantity, is noted like this. This is the general equation of an AC quantity. Its peak value sine of omega t plus minus phi. General equation, it is plus or minus. Phase angle may be positive, phase angle may be negative also. When we measure the phase angle in upward from the x axis, we will take it as positive, and when we measure the phase angle below the x axis, this phase angle will be taken as negative. So this phase angle is taken as negative, this phase angle is taken as positive. So this is meaning of phase angle. And now consider the instants below, or consider the 3 cases below. When phi is 0, what does it means? It means phi 0, it represents purely sinusoidal wave or standard quantity, standard quantity, like it will be represented as I is equal to Im sin omega t, because plus or minus phi is not here, phi is 0. And what will be instantaneous value at this? When phase angle is 0, instantaneous value of the AC quantity at time t is equal to 0 will be 0. Instantaneous value of the AC quantity at time t is equal to 0 will be 0. This is meaning of phase angle. This can be seen from this waveform. Phase angle 0 means phase angle 0 means the value of the quantity at time t is equal to 0 is 0 and it is increasing sinusoidally like this. And this is the waveform. In phasor, we have to show our phasor along the x-axis. So, this diagram represents 0 phase angle, and for 0 phase angle, now it is clear that the phasor will be here and the waveform will be like this, means it is starting from 0. Now, suppose case 2, positive phase angle. When positive phase angle means, what is meaning of positive phase angle? We have explained positive phase angle. When we measure the angle above x-axis, we take it as positive, and when we measure the phase angle below the x-axis, we will take it as negative. This is meaning of negative phase and positive phase. So, for positive phase, when the phase angle is positive, means phasor is somewhere above the x-axis, then the instantaneous value of the AC quantity at that time will be something positive, and which you can see from this waveform. So, this is the phase angle positive, phasor will be here. It means it has some positive value at time t is equal to 0. What is meaning of this? It has some positive value, right? Means at this time instant, when we see the projection of this phasor on y-axis, so projection of this phasor on y-axis is something this much, yani something positive, this projection of this phasor on y-axis. So, this is represented here. At time t is equal to 0, it has some positive value, means positive phase angle indicates some positive value of the quantity at time t is equal to 0. Similarly, negative phase angle, this is the case of a negative phase angle. Negative phase angle means when the phase angle is negative, and this phase angle may be our phasor exactly for this waveform, for this type of waveform. Here we can see that the AC quantity has negative value at time t is equal to 0. At time t is equal to 0, it has some negative value, and this negative is increasing. Increasing means it will go to maximum and then again decrease and come to 0 and go in positive direction, maximum, 0 and so on. So, for this waveform shown here, the phasor should be here, not here. So, it should be this much of phase angle. Phase angle is this much, you can say phase angle is this much negative phi. This is negative phi. So, this is negative phase. Phasor we in this diagram it is incorrect. Actually, it should have be here. It should be here. So, this is negative, because how to correlate it with this diagram? This we know that this phasor or line continuously rotating in anti-clockwise direction. So, now suppose at time t is equal to 0, it was having some negative value, and after that it is showing that the negative value increases and become maximum negative positive, maximum negative after some time. So, for this its projection should be on y-axis should increase. At this time it is projection is this much, and after some time when it aligns here, its projection will be this much, yani from this negative to this maximum negative. So, this phasor should be here. I want to explain that. So, this is meaning of negative phase angle, means when the AC quantity is having some negative phase angle, its instantaneous value at time t is equal to 0 is having some negative value. This is meaning of 0 phase angle, positive phase angle and negative phase angle. Now, phase difference. Sometimes it is said that these AC quantities has some phase difference, or we can say this AC quantity is leading and this AC quantity is lagging. So, what is meaning of leading or lagging in case of our AC quantities? So, suppose we have two AC quantities. One is voltage represented as small e is equal to capital EM sin omega t, and other is our current represented as IM sin omega t, and the peak value of voltage is greater than peak value of current in numerical values. It means if we represent this voltage and current in phasor form, so we will say that this is our voltage phasor and this is our current phasor at time t is equal to 0. EM and IM are shown, and they are continuously, they will be naturally AC quantity, we have represented them in phasor form. So these phasors will be continuously rotating, and we can see that their projection on y axis will be increasing simultaneously, and at this particular time they will be completely aligned against y axis, and their projection will be the peak value of EM here and peak value of IM here. So these two voltage and this current, this AC quantity and this AC quantity are said to be in phase because they are aligned on the same axis, and they will always be aligned while they moving because they have the same frequency, because we are consider two alternating quantities having same frequency. So since frequency is same, their angular speed omega is also same, because we know angular speed, it is 2 pi f. So if frequency is same, their angular speed will also be same. It means when they are in phase, they will be continuously aligned because their frequency is same, their angular speed is same, and their waveform will be, this is the waveform of current, this will be the waveform of voltage. So this is meaning of the voltage E and I are in phase, and there is no phase difference. There is, here we can say, in other words, there is no phase difference between E and I. In these two AC quantities, there is no phase difference. They are in same phase, right? Now consider the case I is lagging with E. I is lagging with E, or in other word, they are not in phase, right? So how, suppose in our case we have taken E is equal to EM sin omega t and I is equal to IM sin omega t, and EM was greater than IM. So how we can represent them when they are not in phase, or in other words, I is lagging E. So how we can represent them in phasor form, and how we can represent them in your waveform. So this is here shown in the phasor diagram. This is our, suppose this is our EM, position of phasor EM, then the position of phasor IM is here, because they both will be rotating continuously with the same speed. When we consider our AC quantities, we consider them of the same frequency. So they will be rotating with equal angular speed, and their waveform, they are out of phase, you can say, or we can say I is lagging with E. I is lagging with E. How we can say I is lagging? They are continuously rotating. Now they consider their waveform. Consider their waveform. I is lagging. How we can say that I is lagging E? By observing their waveforms, right? And how to observe their waveform? How these phasors represent AC quantity, we have explained. Again, you can consider the projection of IM and EM on y axis, then you will get the waveforms like this is the waveform of EM, this is the waveform of I. This is the waveform of current, this is the waveform of voltage. Since the this length is larger than Im, hence the peak of E is more than peak of I, and we can see that the peak value here we say I lagging E. What I mean? Peak of I comes after peak of E. You can see that peak of I, this is the peak of I, right? It comes here at this angle, right? And this is the peak of E, it comes at, suppose this angle is theta 1 and this angle is theta 2, measured from the same axis. So theta 2 is greater than theta 1. It means phase of I या peak of I comes after peak of E. So since we can see that the peak of E, peak of I, the angle at which peak of I occurs is greater than the angle at which peak of E occurs, and it means the peak of I comes after peak of E. That's why we call I lags E, I lags E दूसरे शब्दों में, ठीक है. तो दिस इज I lagging E waveform and phasor diagram. We are showing both waveform as well as phasor diagram. Now we can see another case when I is leading E. I is leading E. We have same E, we have same I, but they are the case of leading is reverse. In initial case, I was lagging E. In this case, I is leading E. I is leading means I phasor is here above x axis and E phasor is here along x axis. This means this phasor is leading. This leading, when it will be leading, when we see the waveform of I, its peak will come before the peak of voltage waveform, that is E waveform. We can very easily consider their projection. This is the at this instant shown here, the projection of current is this much, projection of current is this much, and projection of voltage is 0. So we accordingly projection of current is this much and projection of E is 0. So accordingly current value at time t is equal to 0 is this much and voltage value is this much. So and when we consider their projection after some time, so here the peak of current and here is the peak of voltage. So suppose we can very easily see that peak of current comes earlier than peak of the voltage, which is here at this angle. So it means peak of current comes earlier than the peak of voltage, hence current is leading the voltage, or I leads E. This is meaning of leading. I leads E, or you can say E lags I. Both meaning is same. I leads E or E lags I. ठीक है, meaning of both is same. We can say in any of the forms. The next, phasor diagram. What is meaning of phasor diagram? Phasor diagram, what is a phasor diagram? Suppose we have so many AC quantities. The phasor diagram means, and these phasors are rotating continuously. So what is the phasor diagram? A phasor diagram is a diagram which represents the exact phase angle between these AC quantity at a particular instant. At a particular instant. Suppose phasor diagram, how we can say? And this phasor diagram is actually still picture. What is a phasor diagram? It is still picture of AC quantities. There may be so many 2, 3, 4 AC quantities. It is a still picture of AC quantities at a particular time. At a particular time. It is still picture of AC quantities as a particular time. Suppose we were considering two AC quantities, current and voltage. Now what is the phasor diagram? There it is represented by the location of these AC quantities when it is considered at a particular time, or suppose it is photograph of the phasor quantity is taken at a particular instant. Suppose at some instant they will be aligned x axis both. We are showing the phasor diagram of a quantity having same phase difference, or they are I and E in phase, they are in phase, and we are showing the phasor diagram. At some time they will be here, and after some time, since they are continuously rotating, they will be along the y axis, that is this position, and after rotating again they are rotating, so they can come here, and again they are rotating, they can go here. So this is the still picture of the phasors at different times, you can say, at different time instant. So this is meaning of your phasor diagram of different AC quantities, right? Consider the case when I is lagging by an angle phi with respect to E, right? I lags means consider the case when I is lagging by an angle phi with E. Suppose E is represented as this much, and suppose I is lagging with E, it means here phase angle is 0, omega t plus minus something not there. Here how we can say it is lagging, means after omega t minus phi is there. Minus phi means I is lagging E by a angle phi, means the phase angle is measured below x axis. So this particular, at a particular instant, E will be here and I will be here, and it is clear that I is lagging E. I is lagging E by an angle, and in this case we have taken their photograph. They are continuously rotating in anti-clockwise direction. We have taken photograph at one instant. We can say that this is the photograph after some time when EM becomes here and IM comes here. So this is here, and this is further rotating. So suppose EM aligns negative x axis. So this is also a diagram when the AC quantities are EM is here and I is here. They are continuously rotating, so they will be continuously changing their location. So phasor diagram is nothing but a still picture of our phasors taken at a particular time, and when we take picture or photograph at different times, their locations will be different. So this is meaning of phasor diagram. So in this lecture we have discussed about what is meaning of phase angle, what is meaning of leading or lagging of AC quantities. So this is very important, which quantity is lagging, which quantity is leading with respect to other quantities, right? And this is very important in calculations, numerical calculations in this unit, second unit, analysis of AC circuits, and we will discuss their importance in numericals in further lectures. Okay, thank you.